Flexis QE 32-bit ColdFire V1 microcontrollers, Freescale. Welcome to this training module on Freescale Flexis QE 32-bit ColdFire V1 microcontrollers. This training module provides detailed information on the MCF51QE microcontrollers. From its inception, ColdFire has been designed to provide a compatible family of processor cores that are architected for system-on-a-chip design flows and reuse. The entire family has been 100% synthesizable since its inception in 1995. The cores use a standard rising edge D flip-flop implementation, which is designed for test-friendly and easily adaptable to a wide range of process technologies. ColdFire has always had a strong embedded debug architecture which allows common development tools to be used for Freescale products as well as customer-specific designs. The core architecture includes support for a coprocessor interface to accelerate operations at the instruction or function level. An example is our Cryptographic Acceleration Unit, the CAU, which has been included on a number of devices. The CAU provides a significant performance boost to a number of security algorithms popular today. The MCF51QE112, MCF51QE64, and MCF51QE32 are members of the low-cost, low-power, high-performance version 1 ColdFire family of 32-bit microcontrollers. All microcontrollers in the family use the enhanced V1 ColdFire core and are available with a variety of modules, memory sizes, and package types. CPU clock rates on these devices reach 50.33 MHz. Peripherals operate up to 25.165 MHz. Through an optimized architecture that provides lower operating voltage and current, these Flexis devices offer industry-leading ultra-low power benefits to minimize operating costs and extend battery life. The data table presents the current draw in a number of operating modes, including run mode with CPU operation at 2 MHz and full speed 50 MHz, and low power run mode with CPU operation at 32 kHz. It also shows Stop 2, the lowest power mode, with dissipation of 370 nanoamperes for both devices. Stop 3, another low power mode, and finally the wake-up time from exiting Stop 3 as 6 microseconds for the MCF51QE128 device. The V1 core is a variable length RISC architecture and implementation supporting revision C of the ColdFire instruction set architecture. The implementation includes 24-bit address and 32-bit data paths, and the core design optionally supports inclusion of various execute engines like an integer divide, multiply accumulate engines for both Mac or eMac, and the cryptographic acceleration coprocessor. The V1 programming model supports the standard ColdFire definition, which includes a user mode model containing 16 general-purpose 32-bit data and address registers, a 32-bit program counter, and an 8-bit condition code register containing indicator flags reflecting the results of the instruction execution. The supervisor mode model adds the status register, another stack pointer, a vector-based register used during exception processing, and a CPU configuration register which provides software control over a number of key hardware configuration variables. V1 ColdFire cores comprised of two separate pipelines decoupled by an instruction buffer, instruction fetch pipeline, IFP, and operand execution pipeline, OEP. The IFP is a two-stage pipeline for prefetching instructions. The prefetched instruction stream is then gated into the two-stage operand execution pipeline, which decodes instructions, fetches the required operands, and then executes the required function. Because the IFP and OEP pipelines are decoupled by an instruction buffer serving as a FIFO queue, the IFP is able to prefetch instructions in advance of their actual use by the OEP, thereby minimizing time stalled waiting for instructions. The Rapid GPIO module provides a 16-bit general-purpose I/O module directly connected to the processor's high-speed 32-bit local platform bus. This connection to the processor's high-speed platform bus plus support for single-cycle, zero-wait state data transfers allows the RGPIO module to provide improved pin performance when compared to more traditional GPIO modules located on the internal slave peripheral bus. This module is a memory map device. The data registers can be accessed directly via the alternate addresses which support set, clear, and toggle functions using simple store instructions. The interrupt controller is intended for use in low-cost microcontroller designs using the version 1 ColdFire processor core. In keeping with the general philosophy for devices based on this low-end 32-bit microcontroller, the interrupt controller generally supports less programmability compared to similar modules in other ColdFire microcontrollers and embedded microprocessors. However, this interrupt controller provides the required functionality with minimum silicon cost. The ColdFire processor architecture defines a 3-bit interrupt priority mask field in the processor's status register. This field and the associated hardware support 7 levels of interrupt requests, with the processor providing automatic nesting capabilities. The MCF51QE microcontrollers contain a rich set of peripherals, including 24-channel 12-bit analog-to-digital converter, 2 analog comparators, 2 serial communications interfaces, 2 serial peripheral interfaces, 2 I2Cs, and timers. The analog comparator provides a circuit for comparing 2 analog input voltages or for comparing 1 analog input voltage to an internal reference voltage. The SCIs offer asynchronous communications, 13-bit break option, flexible baud rate generation, double buffered transmit and receive, and optional hardware parity checking and generation. The integrated circuit, or I2C, provides a method of communication between a number of devices. The interface is designed to operate up to 100 kilobits per second with maximum bus loading and timing. V1 ColdFire cores implement a fixed address map with a 24-bit address space. This provides a 16 megabyte definition, which is sufficient for the devices targeted for this application space. Even though the address space is restricted to 24 bits, we still represent addresses as 32-bit values because there are still certain hardware structures that retain the full vector width. The system address map is partitioned into 4 regions: Flash, based at 0, RAM, based at hex 800000, the Rapid General Purpose I/O module, based at hex C00000, and a 32 kilobyte region for all of the slave peripherals. There are 2 programming models configurable: user mode and supervisory mode. The user programming model includes 16 32-bit general-purpose registers split equally into 8 data registers and 8 address registers. There is a 32-bit program counter which defines the current instruction being executed and an 8-bit condition code register, which contains indicator flags to record the results of previous instructions execution. This includes flags to signal a negative result, 0, overflow, and a carry out. These flags are used by condition branch registers to determine whether the branch should be taken or not. The supervisor programming model includes all of the user registers plus a status register, another stack pointer, a vector base register used during exception processing, and a CPU configuration register, which provides software control of hardware configuration settings. Here shows the comparison of different MCF51QE series regarding its flash memory capacity, SRAM, interfaces like I2C, SPI, analog to digital converters, ICS, KPI, KBI, and packages available. The EVB QE128 board has been designed for the evaluation, demonstration, and debugging of the Freescale Flexis QE128 microcontrollers, including the MC9SO8 QE128 and the MCF51 QE128. It can be used as a standalone application or can be controlled by a host PC via its built-in microDART interface. The Demo QE128 demo board is a low-cost development system designed for demonstrating, evaluating, and debugging the Freescale microcontrollers. The board supports two interchangeable plug-in daughter cards to quickly evaluate the 8-bit SO8 and 32-bit ColdFire V1 QE128 microcontrollers. CodeWarrior Development Studio for microcontrollers is a single tool suite that supports software development for Freescale's 8-bit and 32-bit ColdFire V1 microcontrollers. Designers can further accelerate application development with the help of a processor expert, an award-winning rapid application development tool integrated into the CodeWarrior tool suite. The MCF51QE V1 ColdFire core was designed to be used by applications that have reached their performance limit on 8-bit processors but want to reduce the time to market for higher performance implementations. Some of these possible applications include security systems, health monitoring systems, home appliances, and many, many more. The V1 ColdFire core is also perfect for designers interested in achieving a low-cost and low-overhead link to future 32-bit designs. The blood pressure monitor reference design demonstrates how the sensing, data communications, and processing capabilities of the Freescale products interact to create a complete medical handheld solution. This blood pressure monitor design was crafted to serve as reference for those designs that need expansion flexibility. Enabled to use both the 8-bit MC9 SO8 QE128 and the 32-bit MCF at 51 QE128.